Good morning, everyone. It gives me great pleasure to welcome you all to the 18th edition of our Generic Talk series. Today, we embark on an exciting journey into the realm of zero to advanced data science techniques in disease prediction. Before we begin, everyone, it gives me great pleasure to welcome you all to the 18th edition of our Generic Talk series. Today, we embark on an exciting journey into the realm of zero to advanced data science techniques in disease prediction. Before we begin today's session, let us take a moment to recognize the remarkable vision and commitment that have paved the way for this gathering. The unwavering support and guidance of our institution's leadership ensure that we continually benefit from exceptional opportunities to learn, grow, and innovate. To officially commence today's program, I'm delighted to invite our esteemed principal, Dr. K. Mohammed Junaid sir, to deliver the welcome address and set the tone for this promising day. To learn, grow, and innovate. Please, sir.
Thank you, madam. Thank you. So good morning, one and all, joining in this Generic Talk series organized by RMK Engineering College. We are very happy to have our eminent resource person, Ms. Dr. Munesh Chandra Trivedi, Professor of Computer Science and Engineering Department, and also heading in this ICTC and Computer Science Computer Center, Faculty of Engineering and Technology from Bhopal. PSS CIVE, an Apex institution of Ministry of Education, Government of India, and also a constituent unit of NCERT. Really, we are very fortunate to have such an eminent personality to host this Generic Talk series on the topic Zero to Advanced Data Science Techniques in Disease Prediction. On behalf of our respected chairman, sir, all the members of the management, faculty members, students, and my own behalf, I wholeheartedly thank and welcome Dr. Munesh Chandra Trivedi, Professor from Bhopal, and also welcome all the faculty members and HOD of Computer Science and Design Department of RMK Engineering College. Really, this Generic Talk series, sponsored by our management, will definitely help not only our students, all the students and the viewers. They are going to view this Generic Talk series in future because the topic selected or provided by our eminent chief guest is Zero to Advanced Data Science Techniques in Disease Prediction. So this is the need of the day because the inventions today is going to help the human being to predict the diseases, and also it will be very, very helpful with respect to the advancements in the health sciences, which will be very, very useful for all the human beings in the world. So that is why I request each and every one of you to take part in this session. And if you have any queries, so that please ask your queries. Definitely our eminent resource person will help you to clear all of your doubts with respect to this particular topic. At this juncture, I would like to thank our management for providing this great opportunity to all of us to host this event by RMK Group of Institutions. I also would like to thank HOD CSD, Dr. Tangaramya Madam, and the faculty team from Computer Science and Design Department for identifying this suitable resource person from Bhopal to deliver this Generic Talk series today. And also, thank you. Wish you all the very best.
Thank you, sir. Thank you, everyone. So thank you, Principal Sir and Professor Tangaramya Madam, for giving the opportunity to share the experience.
Yeah, sir. Thank you, sir. It's my privilege to introduce the guest of the day, Dr. Munesh Chandra Trivedi, sir. Professor Munesh Chandra Trivedi has over 20 years of experience in computer science and engineering, having served in esteemed institutions across India. He has held various administrative roles for more than a decade, including Dean Academics, Head of the Department, TQIP Coordinator, PG Coordinator, and EDC cell coordinator. Currently, he is a professor of computer science and head ICTC and Computer Center of PSS CIVE Bhopal, a constituent unit of NCERT under the Ministry of Education, Government of India. Previously, he was an associate professor associated with National Institute of Technology, Agartala. He acted as a position of director at the Rokia Engineering College, Alamkar. Professor Trivedi has filed 78 patents, including 59 national and 19 international patents, out of which 45 patents have been granted. He has authored 16 textbooks and published 198 research papers in reputed international journals and conference proceedings. Additionally, he has edited 38 books for Springer Nature. He has successfully supervised 17 PhD students and received numerous accolades, such as Young Scientist Visiting Fellowship, Albert Einstein Research Scientist Award, Best Senior Faculty Award, Outstanding Scientist Award, Dronacharya Award, Author of the Year, and Vigyan Ratan Award from various national and international forums. Really, it is our pleasure to have you for today's session, sir. Thank you for being with us today. Over to you, sir. Thank you.
Thank you, madam. Thank you, madam.
Dronacharya Award, Author of the Year, and Vigyan Ratan Award from
Thank you, ma'am, for that insightful and motivating introduction. The moment we have all been eagerly awaiting has finally arrived. It is with great pride and honor that I
Madam.
welcome our distinguished guest, Dr. Munesh Chandra Trivedi, Professor CSE and Head ICTC and Computer Center, Faculty of Engineering and Technology, Bhopal. Please join me in extending a warm welcome as we invite Dr. Munesh Chandra Trivedi to enlighten us on the topic of zero to advanced data science techniques in disease prediction.
Madam, make me
Please, sir.
co-host.
Please join me in
Again,
yes,
that-
sir. Welcome as we invite Dr. Munesh Chandra Trivedi to enlighten us on the topic of zero to advanced data science techniques in disease prediction.
Madam, make me
Please, sir.
co-host.
Please join me
Again,
yes,
that-
sir.
So I hope the screen is visible.
Yes, sir.
Make me co-host. Again, that- So once again, good morning to one and all, and thank you to the RMK
Yes, sir.
Engineering College for giving the opportunity to share the experience. And a special thanks to the Principal Sir and Professor Thangaramya Madam. So today we will discuss like what are the current research is going on in for the disease prediction, like brain tumor, prostate cancers, and others, and how we can proceed further. Principal Sir. So we will discuss like some of the problems in that particular domain. So today we will have this outline. Is happening. So like whenever we are talking about the data science, so data science is a wider term, like collection of large amount of data, and especially whenever we are talking about the healthcare sector. So healthcare sector is a widely used term, and that basically involve the improvement of medical services in order to serve the medical demand of people. So why the data science is too much necessary in healthcare? So whenever we are talking about the healthcare data, So healthcare data, we have like clinical data, we have the omics data, and we have the sensor data. So when we are having the large amount of data, so how we can get the relevant data that is basically help in the disease prediction. So if we talk about the clinical data, so clinical data basically includes the electronic health record. Like if any, whenever any patient is coming and we are getting like some medical reports. So if we are converting that record into the electrical form, so that data is normally termed as the clinical data. So clinical data is nothing but the electronic health record of the patient that is collected during the ongoing treatment. Whenever we will talk about the omics data, so omics data is one of the high dimensional data comprising genome, transcriptome, proteome, and data types. So this is like the normal clinical. What is the difference between the normal clinical data and omics data? So normal clinical data is simply collected during the ongoing treatment. Whatever the omics data is having the high dimensional data that will like include all the aspect related to that particular data. And third type of data, that is the sensor data. So sensor data is basically collected from the various wearable and wireless sensor device. And that is basically collected to improve the disease predictions. So to handle this raw data, because all the clinical data, whether we are talking about the clinical data, whether we are talking about the omics data or the sensor data, so that data is basically in the raw form. So just to handle this raw data is very difficult. And another point is that we are having the large amount of data. So which data is related for our disease prediction, whatever disease we are going to prevent. So how we can like identify which disease is there and what medication is required. So to handle this large amount of data and to handle this raw data is very difficult. So like how the data science provide the opportunity to healthcare industries in the collection of data, in the organization of data, and analyzing of these data in the most efficient manner, because that is the requirement of identification of the disease. So data science, as we have all know, that data science is basically an interdisciplinary field, and that is basically focusing on extracting knowledge and insight from many structured as well as unstructured data using some scientific methods like data mining techniques, the machine learning techniques, the big data. So data science, especially in the healthcare, has a very important role. And whenever, like as we have discussed, that the three types of data in the healthcare industry. So we are having the large amount of data and raw data. So this using this large amount of data, the combination of large and complex data, as we have discussed, include like some social media data also, some genomic information also, some digital body data, and even data from the wireless device. So the data science techniques will help in analyzing this data, this large amount of data, using some machine learning techniques, using some artificial intelligence tool, so that how we can process with the unstructured, because whenever we are talking about the data, so if the data is structured form, then we have to use different technique. And if data is in unstructured form, we have to use different techniques. So we have to identify like which techniques is good for which particular data. So if we talk about the data science use cases in healthcare, so first is data science for medical image analysis. Like we have to analyze the image, whether it is CT scan image, whether it is X-ray image, whether it is ultrasound image. So how we have to analyze that medical image. Another use cases is providing virtual assistant for patient and customer support. If any customer is unable to visit the hospital, so like how we can provide the virtual assistant by going through report and having the online conversation. So that is also like one of the use cases of data science in healthcare. Third point that is related with data science use cases in healthcare is genetics and genomics. That is also possible by using the data science techniques in the healthcare. And another is data management and data governance that we have to like discuss today, how we have to like analyze the data, how we have to process the data. And last but not the least, the predictive analysis and disease prevention. So that is basically focusing on how we have to do the thorough analysis of the data collected, whether it is sensor data, whether it is genomes data, whether it is the electronic record of the patient. So how we have to take in forward, if the unstructured data is there, then how we have to forward, and if it is structured data, how we have to like identify the relevant data that is basically focusing on that particular aspect. So data science and machine learning in healthcare. So as we are all are discussing that if we see this particular figure, AI and robotics, so like if in the training also, and in order to early identification of disease also, and if we are able to identify the disease at the early stage, what type of treatment we have to focus, that all can be decided if we are able to analyze the data properly related to any particular patient. So healthcare sector is being transferred by the ability to record massive amount of information. That is, we all know that we are getting like a large amount of data in every day we are getting the large amount of data related to any particular disease. And whenever we are talking about the machine learning use or data science use in the healthcare, so as we know that machine learning provide a way to automatically find pattern and reason about the data, and it basically enables the healthcare professionals to move to personalized care, known as the precision medicine. So this analysis of big data using the machine learning techniques or using the data science techniques is very important nowadays. So how like machine learning can help in the early diagnostic of any particular disease? So recently, as we have seen, that hospitals have started using machine learning to speed up the process of diagnosis and analysis. And doctors can get support in diagnosis to reach the treatment phase as quickly as possible. So how this is possible? This is possible by using the machine learning techniques, the data science techniques, and because of the advantage that whenever like if we are getting the all the electronic record of any particular patient, like in last 1 decade, 2 decade, or from like how many disease he are suffering from. So that with the help of that particular things, like we can easily identify the things. And as we know that related to any patient and even the other patient who are suffering from the same disease, so we are having the huge amount of data. So it is not possible that we analyze all the data that is related with that particular disease. So once we are applying the machine learning techniques and data science techniques, so they are not only analyzing a particular patient with their previous record, as well as they are also taking into consideration the related patient in that particular domain who are suffering from the same disease. So if we are getting like thousands or lakhs of patient record on any particular disease, then we are accurately able to identify like what medication is best suitable for the early recovery of the patient. That is like one of the, you can say, the major advantage of using the machine learning techniques and data science techniques in the disease prediction. Because here we are not only taking into consideration the patient's record, apart from that, we are also taking into consideration around the world who is suffering from the same disease. And manually, like if we are whenever we are going to the hospital and we only like identify the disease based on the this particular problem, so that is not like easily possible for any doctor to accurately identify the disease and give the proper treatment. I am giving you like one of the example of how this is like beneficial. In 2016, like one of the patient who is suffering from some disease, and even they have visited around all the best hospitals of the India. That patient is very known to me. So they have visited even the AIIMS Delhi, and the doctors are unable to identify what is the disease is there, because the patient is like having like problems such that he simply get the fever, and after the fever his whole body is not responding. If you put hand that is not hanging, so all the parts of the body after the fever, they are not like responding. And the relatives, the parents of that particular patient, they have like consulted the AIIMS Delhi, they have consulted the Bardhaman Mahavir Hospital Delhi, and all the best hospital, but no one is able to identify the disease. So then one of the senior doctor of the AIIMS Delhi, he said, we are unable to identify. We have like video conversation with some medical college in London. So he like used his own connection and he discussed the case of the patient with that. I am forgetting the name of that hospital in the London, but he discussed thoroughly with that particular doctor. So doctor said that we are having some tools and we will analyze. You please send the report of the patient. So suddenly that particular doctor of the AIIMS Delhi, they have sent all the scanned electronic record of the reports to the London, and they have used the tools and they identify the disease like within a day, and that is enabled like here in India, we in the like 2 months we are unable to even identify the disease. So that is the benefit of the tools. So now even in India also, like most of the hospitals, we are using this data science and machine learning techniques. So that is like sometimes what is happening, like any particular disease that never came to the doctor, whether we are visiting any place, Delhi, Chennai, Kolkata. So if we are like frequently visiting a hospital, if in that particular hospital that disease patient never came and doctor has not handled that particular disease, so what will happen? The doctors are unable to identify the disease. But if they are using the tool, they can like mesh the reports of the patient with around the world. So this statistical techniques, like how the machine learning is working. So machine learning, as we all know, is a field of computer science that uses statistical techniques to give computer system the ability to learn with data and without data being explicitly programmed. So like, as we know that in machine learning, we are using the two types of algorithm, supervised learning and unsupervised learning. So we are having the facility that we can learn with the help of data also and even without the data also. And when we are like seeing the algorithmic use, so machine learning algorithms, we are having the various algorithm that is related with the supervised learning and unsupervised learning. The machine learning algorithm use computational methods to learn information directly from the data without relying on the predetermined equation to the model. And apart from that, like whatever the size of data is available, so like we can certainly like improve the performance on the data sample, and that will help in the early identification of disease. So as we are discussing about the types of machine learning, so we first one is like we all know that supervised learning. So supervised learning, which trains a model on non-input and output. So in case of supervised, we know the input also and we know the output also, and based on that input and output, we are predicting the future output. So like if we are having the in the medical field, if we are having the data of both the input and output, then also by using the supervised learning algorithm, we can predict the disease. And if we do not have the output, then with the help of unsupervised learning methods, like we simply, with the help of clustering and finding the hidden patterns, and based on the input data also, we can like identify. And that is the case that I am talking about from the Medical College of London. So like they are using the unsupervised because they do not know the exact requirement of the patient in India, but they know the inputs that this is the disease, but they do not know what is the disease. So by using the unsupervised learning algorithms, they are able to find out the disease. And another, like if we do want to use the mix of both the approach, so semi-supervised learning, which is simply the mixture of both the techniques, and it is the combination of supervised as well as unsupervised learning algorithm. So if we know certain inputs, if we know certain output, but we do not know all the outputs and all the inputs, then we can go for the semi-supervised learning. That is like basically using the mixture of both the approach, and that is able to find out the disease. Another, the deep learning. So deep learning is also, you can say, the subset of machine learning only. But if the size of data is very large, if the size of data is limited, then we normally go for the machine learning algorithm. But if the size of data is very large, then normally we are using the deep learning algorithm. So that's why the deep learning is basically known as the complex form of the machine learning, because it involves the deep learning and neural network models with many levels of features. So when the size of data is very large, we have the complexity of data is very high, then we are using the deep learning methods. So here, if we are having the thousands of hidden features, lakhs of hidden features in the data, so that is easily possible with the deep learning techniques. So the common application of deep learning in healthcare is recognition of potential cancerous lesion in radiology images. Like if simply we are having the radiology image, whether that is ultrasound image, whether that is CT scan image or other image. So if we are using the deep learning techniques, that is like you, as we have discussed, that it is applicable on the thousand of the hidden feature. So by simply that radical image, radiology image, we can easily identify the disease. So deep learning, if we see about the use in, especially in the disease production, it is continuously increasing, only because that with the help of data we are able to identify the disease, whether that is the radiology image, whether that is any electronic health record. So whenever we are talking about the radionomics, or we are talking about the deep learning, so even if the size of data is large, we can apply the machine learning also. But the advantage over the machine learning to the deep learning is that because they are working on the thousands of the hidden feature, so they are giving like deep learning is giving the better result. So what is unique about machine learning in healthcare? So whenever we are talking about the healthcare sector, so it is life or death decision. Like because whenever we are talking about the healthcare sector, so healthcare sector is very crucial, because here, like whenever we are analyzing any particular data, so here it is a life or death decision. So like we need the robust algorithm. We have to check and balance the deployment also, and we have to be need a fair and accountable algorithm, so that whether we are analyzing the radiology image, whether we are analyzing other electronic health records, so like we have to take into consideration the right kind of algorithm, whether when we have to go for the supervised one, when we have to go for the unsupervised one, and when we have to like go for the semi-supervised. So that is like the clear identification of the algorithm. The clear identification of the data analysis is very much crucial, because we have to be develop a methodology so that we can accurately identify the disease at earliest as possible, and we can suggest the suitable medications. So many questions about like unsupervised learning. So like discovering disease subtypes, like whenever we are identifying some disease, so every disease is having certain sub diseases also. So like how we are able to identify that sub disease, because we do not know the output. We know that is the disease. So what will be the sub disease? That is possible with the help of unsupervised, because unsupervised is working on the continuously refinement of the data. So that's why that techniques is helping even in the identification of subtypes disease. And like many of the questions we want to answer, like native use of supervised learning is insufficient. In most of the cases, we are saying that we do not know the exact output. So if we do not know the output, how we, like by using the supervised learning, we can accurately identify the disease. So we can accurately identify the disease with the help of supervised learning when we are having a sufficient data related to that particular disease. So if we are having a related data related to that particular disease, then we can go for the supervised learning. And we do not have then we normally prefer the unsupervised learning approach. So I will discuss like one of the example of this identification of disease. So like how we are like doing the classification of glioma grades into high grade and low grade in MR images using machine learning and data science techniques. So as we are talking about this glioma is related with the brain tumor. So like it is in high grade or it is in low grade. So how with the help of radiology image, how with the help of MR image, we are able to identify. So brain tumor is related with the glioma is related with the brain tumor. So in the field of like medical image analysis, lot of research is going on the brain tumor because it is like one of the most prominent ones. So nowadays the cases of the brain tumors are increasing, and if we take the data of like 2-3 years before, so primarily brain tumors occurs in around 2,50,000 people around the world in a year. So that is like 2-3 year old data. And maybe right now it is around 3 lakhs and making up less than 2% of cancers. But every brain tumor is not cancerous. So if it is not cancerous, then we do not have to worry about that. And if it is cancerous, we have to take the suitable medications. We have to take the proper treatment. So how we will identify that out of 3 lakh or 2,50,000, only 2% are cancerous. So the exact identification whether this brain tumor is cancerous or not. So like, and whenever we are talking about the brain tumors, so every patient is having different shapes. They are having the different sizes. They are having the different appearances. Their color is different. Maybe the location is also different. So it is very like challenging that how we can identify whether the brain tumor is cancerous or not. And another problem is like in the manual detection, it is time consuming and as well as it is prone to human error. But if we are using the data science techniques and machine learning techniques, so like everything we are doing in the automated manner, and your MR image is compared with lakhs of data, with thousands and lakhs of data of around the world, so they are getting the exact picture. And whenever like we want to identify the brain tumor, whether it is cancerous or not, or by the manual detection, so it is not like you can say not possible because we do not have the sufficient data because it vary in the shape, size, color, everything is varying. So how we can identify whether it is cancerous or not? So whenever we will talk about the brain tumor, so brain tumor is of normally of two types. First one is the benign type and second one is the malignant type. So whenever we are talking about the benign type, so benign type brain tumor normally is non-cancerous. The growth rate of benign type brain tumor is very slow. They grow very slowly, do not spread into other tissues very easily, and they have the clear border. So it is clear from this that if any patient is having the benign type of brain tumor, then there is no need to worry because it is non-cancerous and the growth rate is also very slow and they have the clear borders. Another is the malignant type brain tumor. So that is cancerous. Growth rate is very rapidly and involve healthy brain tissues. And another problem is they are having the distorted borders. So if any patient is having the malignant type of brain tumor, so like it is cancerous, and even their growth is very fast. They are not having the clear-cut boundaries. Their borders is also distorted. So like they can display in any of the area. So like we are unable to identify which particular area they are going into. So glioma is most common malignant brain tumor. So here like we are discussing about the malignant type of brain tumors, and one of the malignant type of brain tumor is glioma. So the levels of tumor diagnosis. First, we have to detect the tumor. Then we have to do the tumor segmentation, and the last we have to do the tumor classification. So for the tumor detection, if we are using the traditional machine learning techniques, then we can use the SVM, support vector machine, PNN, BPNN, CCANN, and this is like you can say the level 2 algorithm that is used for the tumor detection. And if we are going for the deep learning, so deep learning, we are having the CNN, convolution neural network, and DNN, deep neural network. So that is like how we have to identify whether we have to go for the traditional machine learning or whether we have to go for the deep learning for the tumor detection. So that we have, like, as I have told, that if the size of data is very large, we are having the complex data, then we normally go for the deep learning algorithm. And if the size of data is limited, then we can use the traditional machine learning algorithm. And even if we do not like have the exact identification of the disease, or we do not have the sufficient data, then also we will prefer the deep learning. After that, we have to do the tumor segmentation. So for tumor segmentation also, we are having both the approach, like traditional machine learning and deep learning. So again, we are having the traditional machine learning. We can use the SVM, PCNN, FCM, and BPN. These are the traditional machine learning algorithms that are used for the tumor segmentation. And for the deep learning, we are having the FCNN, FCDRNN. These are the deep learning algorithm that helps in the tumor segmentation. And for the tumor classification, again, we are using both the approach, traditional machine learning and deep learning approach. And for the deep learning, we are using the CNN algorithm that is used for the tumor classification. And these are the standard algorithm that we use. Even we can use some hybrid algorithm. If we want to do the research in that particular area, like how brain tumor identification. So we can develop a hybrid algorithm. We can suggest a hybrid algorithm. And with that hybrid algorithm, we can do the tumor detection, tumor segmentation, and tumor classification. So if anyone wants to do the research in this brain tumor diagnosis, early identification, so like he can do first, like we have to perform the operations on these algorithms, then we can develop some hybrid algorithm and we can do the tumor detection, segmentation, and classification. So whatever hybrid algorithms we are like presenting or we are developing, so we have to compare that hybrid algorithms result with the traditional machine learning and deep learning algorithm, and we have to prove that this hybrid algorithm is giving the better result in terms of tumor detections, in terms of tumor segmentation and tumor classification. So a lot of research is going on in that particular dimension. Another, as we have already discussed, the key difference between machine learning and deep learning. So as machine learning or deep learning, both are the subfield of AI only. So machine learning is the subfield of AI that focuses on machines being able to learn without being explicitly programmed. And deep learning is subfield of machine learning. It is, so you can say deep learning is the subset or subfield of machine learning, and that basically focus on machine being able to mimic the human brain to perform highly complex AI problems. So as we are discussing, whenever the complexity is very high, whenever we are having the large amount of data, whenever we are having the unstructured data, we will go for the machine learning. If the complexity is low, we are having the limited data and the structured data, we go for the machine learning. So as we are talking about the data feeding, so we give structured data to the machine that build the machine learning model, but we cannot give the unstructured data in the machine learning algorithms, but we can give the unstructured data as a raw input in the deep learning algorithms. And whenever we are talking about the volume of data, so machine learning models can deal thousands of data rows But if we are having lakhs of data rows, if we are having the millions of data rows, that cannot be trained by the machine learning algorithms. So then we have to go for the deep learning models. So deep learning models mostly deals with data sets having millions of data rows. If we are having like n number of data rows, that is possible with the deep learning algorithm. And even the unstructured data, millions of data, highly complex data, that is possible with the deep learning. If we're talking about the training time, so machine learning models will take normally the less time because we are having the limited amount of data as well as the data is structured. But the training time in deep learning algorithm is huge because we are having the large amount of data as well as we are having the unstructured data. So if we are having the structured data and if we are having the limited amount of data, then normally we have to go with the machine learning because it will reduce the training time. Another human involvement. So the human involvement in terms of machine learning. So machine learning models are easy to build, but require human interaction for better prediction. But normally, as we are talking about the deep learning models, so here we are having the millions of data as well, unstructured and highly complex data. So here the human involvement in terms of deep learning algorithm is very limited. If we talk about the feature engineering, so feature engineering is done explicitly by the humans in case of machine learning, but there is no need of feature engineering and in case of deep learning, and here automatically detect the important feature. So from the raw inputs, from the input data only, it will automatically detect the important features using the deep learning algorithm. So like what is the goal of this data analysis? So in case of machine learning, to give the output as close as it is to be expected output. So the major goal of machine learning algorithm is to give the best possible output. But if we are talking about the deep learning, so here, as we are discussing continuously, that we are having the large data, we are having the unstructured data, we are having the highly complex data. So here the continuously refinement is going on, and machines are able to think how to generate the best possible output, generate the right output. So if we talk about the interpreting result, so it is very easy to explain the result of ML model. But if we talk about the deep learning results, it is difficult to explain the result of a deep learning model since it is hard to interpret the output of a complex multi-layered neural network. Support vector machine as like one of the algorithm of the machine learning. So support vector machines, what are the advantage and disadvantage? So as we all know that support vector machine work relatively well when there is a clear margin of separation between the classes. If there is a clear margin between is there, then we can use the support vector machine or SVM. SVM is more effective in high dimensional spaces, and it is effective in cases where the number of dimensions is greater than the number of samples. So if the number of dimensions is large in comparison to the number of samples, and it is also like memory efficient. So if we are like want to have this kind of data, so we can use the support vector machine. In spite of having the many advantage, the support vector machine will also have some of the disadvantage. Like if we are having the large data set, because SVM is a traditional machine learning algorithm. So we are continuously saying that if the large data is there or the complex data is there, then we do not prefer the machine learning algorithm. In that particular case, we are going for the deep learning algorithm. So support vector machine algorithm is not suitable for the large data set because it is the machine learning algorithm. Another is support vector machine does not perform very well when the data has more noise. If the noisy data is there or the target classes are overlapping, then also the support vector machine will not perform good. In cases where the number of features for each data point exceed the number of training data sample, the SVM will underperform. As the support vector classifier work by putting data points above and below the classifying hyperplane. So if the complexity of data is very high, the unstructured data is there, then normally we do not prefer the support vector machine SVM because it is a machine learning algorithm. So SVM is a machine learning algorithm. So now we will discuss like one algorithm from the deep learning also, that is CNN, convolution neural network. So convolution neural network are one of the most popular model that is used today. If you see the research related with the disease prediction, especially in the deep learning, so you are seeing like most of 70 to 80% papers, they are using the CNN only. And why the CNN is so much used nowadays in the disease prediction? Because it is providing a very high accuracy in image recognition problem. Another advantage, it automatically detects the important features without any human supervision, and no human supervision is required in that particular algorithm. And if the size of data is increased, then we can use the deep CNN also. CNN is also like useful, but if we want to improve the more accuracy, then we can use the deep CNN. So CNN, apart from having the many advantage, it is also having certain disadvantage. CNN do not encode the position and orientation of the object. If we want to encode the position and orientation of the object, so that is somehow lacking in CNN. Another lot of training data is required, as CNN is the part of deep learning algorithm, and it is like one of the major requirement of the deep learning algorithm that we require large amount of data. So a lot of training data is required in case of CNN. That is also, you can say, one of the disadvantage of CNN. So if we want to accurately predict the disease, then we have to have the millions of data, and then it is possible, because here we are continuously refining the output. And another is the lack of ability to be spatially invariant to the input data. So sometimes it is not giving the accurate result if we are not having the accurately this large amount of data. So this is like flow chart, how we are identifying the disease. So computer, how with the help of CAD, computer aided system, that is used for the diagnosing the brain tumors. So first, as we have seen, that we have to have the data collection. So the expert radiology, with the help of expert radiologist, we have to collect the radiology data. Then we have to do the pre-processing of the data. For the pre-processing of data, we will use like masking. We'll use the various types of filters, median filters, to refine the data that is collected. After the data collection and pre-processing, we have to do the image segmentation that we have collected with the help of radiology. So for the image segmentation, we will use the histogram approach. We will use the ANN approach. We will use the age-based and region-based clustering. Then we can use the k-means. We can use the fuzzy c-means. These are like some of the approaches that are used for the image segmentation. So once the image is segmented as per the requirement, we have to extract the relevant feature. So for the feature extraction, we can use the wavelet transform. We can use the texture feature and Gabor feature transfer. And once the features are extracted properly, then we have to select the right feature that is suitable for that particular disease prediction. So after the feature extraction, we have to do the feature selection. And for the feature selection, we can use the SBS, that is sequential backward selection. We can use the genetic algorithms. We can use the PSO, that is particle swarm optimization. And apart from that, we can also use the SFS, that is sequential forward selection. So these are like some of the feature selection algorithms. So we can use as per our requirement. So once the feature are selected, and if we suppose we have selected the large number of features, Okay. So during the feature selection, if we are having some less number of features, then we can all directly do the classification. But if the selected features is large, then we can also do the feature reduction. So for the feature reductions also, we can use the ICA, PCA, and ICA is independent component analysis, PCA is the principal component analysis, and another is the kernel PCA, kernel principal component analysis. So we can use the ICA, PCA, and kernel PCA for the feature reduction if the large number of features are selected. So after the feature reduction, if we are getting like the right features that is required for that particular disease identification, then we have to do the classification. So for the classification, we can use the SBM, we can use the ANN, we can use the SOM, we can use the fuzzy, or like CNN also, if the large amount of data is there for the image classification. So after the classification, we will do the performance evaluation of the classified images. So the performance evaluation of the data is done on the basis of like sensitivity of data, specificity of data, accuracy, and dice of the data. So this flow chart is, you can say, is showing all the stages of a computer-aided diagnosis system. And here, it is not necessary that we have to like use every step differently. If the data size is less, or if we are having the less number of features, then we can skip like feature reduction. So depending on the type of disease identification, we can include more aspect, and we can like reduce one of the aspect. So tumor detection stage does not appear because the computer address system assume that tumor is present in the collected data. So whatever the images, whatever data inputs we are giving during the data collection, we assume that all the data that is fed during the data collection is having the tumor. So here we will like start from the tumor segmentation only. We are not focusing on the tumor detection because we are assuming that we are inserting the data that is with the already having the brain tumors. So if we talk about the grading, because in this particular research, we are focusing on the grading. So as we have discussed, that brain tumor is of two types, benign and malignant type. So benign, there is no need to worry because it is non-cancerous. They have the clear boundaries and they do not spread so quickly. So there is no need to worry about if any of the patient is having the benign brain tumor. Second one is the malignant, as we are saying, it is cancerous and they are having the distorted borders and they are like spreading like more frequently. So glioma is one of the primary type of brain tumor. Secondary type is also there. So primary, in case of malignant, there is primary and secondary, two types of malignant brain tumor is there. So in primary, we are having three types, that is meningioma, gliomas, and pituitary. So glioma is having in grade 1, grade 2, grade 3, and grade 4. So normally, if it is lie in grade 1 and 2, then it is called low grade glioma. And if it is lie in grade 3 and 4, it is called high grade glioma. So tumor grade is a way why we require the tumor grade. So tumor grade is like helping the healthcare professionals, healthcare team, so that they can accurately identify the treatment, how like what treatment is required. So if it is grade 1 and 2, then there is there is no need to worry, and we can say with the help of like suitable medication we can treat the patient. But if it is lie in high grade, that is in grade 3 and 4, so we have to take into consideration of the reports, and accordingly we have to suggest the treatment. So as we are talking about the MRI image, we are talking about the radiology image, and MRI is utilized clinically for the medical examination for the presentation of brain tumors. And like we have to focus on certain aspect of the MRI image. And even if we want to accurately identify the disease, so normally for the simple MRI, we can use the multimodal MRI scan. So multimodal MRI scan will help in the more accurately they are able to the identification of this. So whenever we are talking about the multimodal MRI scans, so like we can say we are having the T1 weighted context enhanced image, and we are having the T2 weighted flood attention inversion recovery images. So here we are getting the multi-dimension of the MRI data. So through that multi-dimensional MRI data, we can identify the color, we can identify the shape, we can identify the exact location of the print. So with this, if we want to clearly focus or identification of the disease, so we can use this multi-model so that we can get clear picture about that. Some of the public MRI data sets are available that you can use during your research, like Branex medical images, that is the location. So from this particular location, you can use this data set. And simply in your research publications, you have to only give the acknowledgement that you have used this particular MRI data set for your analysis. Another data set is TCGA, GBM, TCGA, LGG. So this is also like one of the public available data set that you can use for the brain tumor identification and classification. Another is the Fixia that is also available, Harvard Medical School data, and Moffitt cancer research data. Like a lot of data is available. These are like some of the example only. It is not that only these 6 data sets are available. Many others data set is also available. So you can perform your research on this public MRI data set. Sometimes most of the researcher is asking like whether we have to focus only the standard data sets that are available, or we can collect our own data sets. We can collect our own data sets. There is no issue. But the problem of the collection of data set is there whenever we are collecting the health record of the patients from the hospital. So one of the problem is that we do not have the large amount of data. We visit one hospital, 10 hospital, 20 hospitals. So we are not getting the sufficient data. Another problem is there when we are collecting the data, lot of noisy data is there, lot of we have to apply lot of pre-processing to refine the data to the particular standard that is normally required for the research. So it is normally suggested that we will use the standard data set that is available. And if we want to use our own data set, then we have to use like certain medical experts also in our research so that he can help in collection as well as pre-processing of the data. And then we have to do a lot of filtering to make the data at par with the standard of the standard data set. Some of the challenges in the brain tumor segmentation and identification, as we are discussing since initial, that they vary in the shape, they vary in the size, their location is different, and their color is also different. So the difficulty in brain tumor segmentation is there because we do not know the exact location, we do not know the exact size, so how quickly they are spreading. And like when we are like able to identify the location, we are able to identify the size. So like how this MR images, if we are using the simple MR images. So simple MR images, we are not getting the clear-cut picture of like whether they are having the distorted border, whether they are having the clear-cut border. So it is normally suggested that we have to use the multimodal MRI data so that we will get the clear-cut picture of their borders also, their like how quickly they are spreading. Another challenge is related with brain tumor segmentation is the computational cost. So as we are seeing that lot of data is required for the training because So if we are having a lot of data, so like we have to perform the computation. We have to like continuously refine the output. So in order to continuously refine the output, the computational cost is normally high. So what is the significance of study? This classification of glioma into high grade and low grade. So what is the advantage of this study? What is like we have done in this particular research? So one is the importance of tumor grade and type. Like we are able to, with this research, we are able to identify the glioma grade, whether that glioma is in low grade, whether that glioma is high grade. So with the help of this particular research, we are able to identify the grade as well as we are able to determine the diagnostic procedures and we are able to suggest the suitable medication. Another significance of this study is standard diagnosis methods for the glioma. So whether like we have to perform the biopsy, we have to perform the surgery, and which particular procedure is required, that is also possible with this particular study. Another is like challenges in histopathological diagnosis. So histopathological features like is very difficult to interpret, and if any patient data is not accurately histopathological diagnosis, so sometimes that is leading to like very dangerous situation. Like if any patient is having benign type of brain tumor and somehow like due to the mistake or we have not used the right kind of algorithm, like if we are having the large amount of data and by mistaken we have used the like machine learning algorithm. So here that is focusing on the structured data only. And if we are having the unstructured data, so what is happening? They will not deal with the unstructured data. So we are not getting the clear cut pictures. So the identification of right kind of algorithm is also like one of the major challenges in this. And with this study, we are able to clearly identify the algorithm that is suitable based on any particular patient. Another is automated method for tumor classification. As we are saying that we are with this research, we are like developing the automated method for the tumor classification, and that will help in the early identification of the disease as well as that it helps in the identification of grade also, whether it is in grade low grade or whether it is high grade. Another is like accurate tumor grading. If we are able to like identify whether it is in high grade, whether it is in low grade. So with this, we are able to identify like whatever the medication is required, whether we have to do the chemotherapy, whether we have to do the radiation, so whether we have to do the surgery. So like if we are able to identify the grade, so then we can easily do the proper medical treatment. Motivation and objective. So the motivation behind this research is like well adoption of automated medical image analysis and the early detection of brain tumors for reducing that rate and reducing the pressure on human judgment. Because whenever like we are manually identifying any disease, as I have given the example of that one of the disease, that even the AIMS Delhi doctor, they are unable to identify because we have to like compare the medical data with the previous patient's data who have suffered the similar kind of problem. So that is possible whenever we are like developing the computer at system and we are inserting like a lot of data related to that particular disease. So we are able to like identify so it will basically I am not saying that human intervention is not like able to identify the disease. That is also possible. But if we are like using this computer aided systems too, so it is helping in the better identification because it is not only comparing the patient's previous data, it also comparing the data of similar kind of patient who is suffering the same kind of problem. So that is like one of the motivation that we have to develop some computer-aided system so that we can easily perform better in the identification and grading of the brain tumors. The primary objective of this research is to extract the meaningful and accurate information from the image scan with least possible errors. Like we have to reduce the errors, we have to improve the sensitivity, specificity, and efficiency of the brain tumor screening. The main goal of this research is to design efficient automatic brain tumor classification model who helps in the grading of glioma into high-grade glioma and low-grade glioma. And that basically we have to improve the accuracy and as well as we have to improve the performance and also reduce the complexity. So that is the primary goal, that we have to improve the performance, we have to improve the accuracy, we have to reduce the complexity, and we are able to do the glioma grading into high grade and low grade. So like this is like one of the research in this early identification of disease using data science and machine learning techniques. So again, we will quickly like go through all the parts. That implementation flow, first we have to do the MRI data set. Then we have to do the pre-processing. We have to do the segmentation. Then we have to do the classification, and we are getting the low grade and high grade glioma. So from segmentation, I am directly moving to the classification. So that is like general flow. But in between, we can also do the feature extraction. We have to select the feature. We have to reduce the feature. So that basically like depend on what kind of data, how much data, structured data, unstructured data we are using. So according to that, we can also focus on the feature part. So we have to like select the feature, reduce the feature, refine the feature. That is, we have to identify based on structure and structure, large amount of volume of data, and we will do the grading of glioma into high grade and low grade. And when like the proposed methodology, here we are focusing first the training of low grade glioma and high grade glioma data sets. We have to do the pre-processing, then we have to do the segmentation. We have to do the training with the machine learning and deep learning algorithms. Then with the hybrid models that we have proposed, we have to do the training with the hybrid model. And the output that we are getting into the high grade and low grade glioma, we will compare the standard result available. So these are like the proposed methodology. So the state of art in brain tumor classification. So this is like one of the like what the researchers they have done previously. So here we are able to improve the accuracy. We have to reduce the complexity, and we are able to identify the disease and suggest the suitable medication. So this is all about the brain tumor classification into high grade and low grade. If any question from this particular topic, you can ask. Otherwise, I will discuss one more topic, use of multi-parametric MP-MRI images in the prostate cancers. So if any question from any of the faculty members?
If you have any queries, please feel free to ask.
No, sir.
A lot of research is possible in this particular directions. You can start the identification of any disease by using machine learning and deep learning and data science techniques. And even you can suggest the hybrid models also. So no question?
Good morning, sir. This is Haripriya.
Yes, good morning. Good morning.
Thank you for such an insightful presentation, sir. It was so fascinating to hear about this. As trust is a cornerstone of healthcare, I'd like to begin with a question on balancing accuracy and interpretability in models, sir. In healthcare, as trust is crucial, how do we ensure that disease prediction models are not only accurate but also interpretable for medical professionals, sir?
Can you repeat the question?
In healthcare, as trust is crucial, sir. So,
Okay.
how do we ensure that disease prediction models are not only accurate but also interpretable for medical professionals, sir?
Yes, it's very good question. So as you hope you are like listening that I am during the at the time of significance of study. So we are basically focusing that we have to like this is very sensitive sector. Whenever we are talking about the healthcare sector, it is very sensitive sector. So we have to not only focusing on the like early identification of disease, but we have to identify the disease more accurately, and for that, that is possible whenever we are having structured, unstructured, and large amount of data. So if we like perform millions of data, then and thousands of data. So it is normally 100% true that if we are performing the operation on large data on in both type of data, structured and structured both, then we are getting the better output. So that's why the continuously refinement of output is very much necessary whenever we are talking about any like disease prediction in the healthcare. So that is like one of the even you can say the research dimension is also there that we have to continuously improve the output. Because if we are performing the operation only on the unstructured or only on the structured or limited amount of data, then like we are training the model, we are developing the computer aided system based on that data only. But if we are like having the data of both the type, unstructured data is also there, structured data is also there, then it is like we are combining all types of features. So that's why it is suggested that whenever you are performing the research, especially in the medical domain, apply all the like possible algorithms. You first apply the machine learning algorithm, then apply the deep learning algorithm, then you compare both the algorithm, and then you like develop some hybrid algorithm and compare the result, again perform the refinement and continuously train your model on the new data that is available. It is not like suggested that if you are using any particular database, you perform your operation only on that particular database. No, you have to perform your operations. You have to apply the algorithm on the multiple data sets that is available. So if you are performing on the multiple data sets, what is happening? Like you are accurately getting the clear cut picture, like how accurately you are getting the result. So if you are getting the similar kind of result in all the databases, it is like normally assumed that we are going into the right direction. So I hope I am able to answer your query.
Yes, sir, I could understand you. Thank you, sir.
Thank you, madam. So if no more question, we can proceed to another topic. That is
Hello, sir.
Yes.
Sir, actually, I have another question.
Yes.
Since personalization of healthcare requires handling of sensitive data, how do you address the potential of re-identifying of de-identified healthcare data, and what measures are in place to handle these risks?
Yes. So as if you have like listen the example that I have told. So many of the times the healthcare professionals, whenever we are giving any like medical reports to the doctors, so they are not able to accurately identifying the disease. Like the case that I have told is not the normal case. That I am forgetting the name of the disease. So that is very unique disease. So whenever like we are having any unique disease is there, or whenever like sometimes like some patients say, "Ki I never feel any problem." Suddenly how this like brain tumor is developed. So that is also the like case is there, because patient do not feel any of the problem, and suddenly it is like having too much problems that he is sometimes it is having that he is or she is unable to survive. So whenever we are performing the operation on the patient data with both types, unstructured and structured data, then like we have to like identify the disease. Even like whenever like we see the MRI image, MP MRI image or multimodal MRI image, so simply by seeing the image, in the image, there is nothing is visible. There is no disease, but the patient is suffering. So how like that is possible? That is possible. Like we have to use the multi-parametric and we have to use the multimodal MRI images, and we have to do the lot of like comparison of that image with the standard data set. So like whenever we are talking about the healthcare sector, so we have to like accurately the disease identification is very much important. So whenever we are performing the operations on the this MRI images, so if nothing is visible in the image, how we have to like identify the disease? So that is possible if similar kind of case arrives previously, that in that particular normal MRI image or that particular multi-parametric MRI image, nothing was visible, but the patient was suffering from that particular disease. So in this way, this research is helping, and you can like improve, and the continuous refinement is required in that particular direction. Hello.
Yes, sir. Thank you for a wonderful insight, sir.
Thank you, madam. Thank you. So the use of MP MRI images in the identification of prostate cancer. So prostate cancer is another like one of the, you can say, is primary cause of cancer in the men, and it is one of the top 10 types of cancer that kill the men the most often. And for this, we are using the multi-parametric MP MRI images. And with the help of this MP MRI images, we can early identify the prostate cancers. And this practice is in practice from, you can say, the last decade, from last 10 years. And this basically helping in the identification of prostate cancer, the delineation of prostate cancer. And apart from that, whether we have to go for the biopsy or we have to like do some other assessment, or how like we have to identify the grades also. So what is the difference between normal MRI image and MP MRI image? So normally, as we have discussed in last presentation also, the MRI images are T1 weighted and T2 weighted scans. But whenever we are talking about the multi-parametric, that is MP MRI image, so MP MRI image is having the T1 and T2 weighted like the normal MRI image. Apart from that, they are having the DWI and DCE, that is diffusion weighted image and dynamic contrast enhanced sequence. So they are having like two more feature in comparison to the MRI image. So these two more features will help in detecting the prostate cancers because they are giving the multi-featured MRI images. So whenever we are talking about the prostate cancer, so here we have to like grade the lesion. So lesion may be in category 1, lesion may be in category 2, lesion may be in category 3, lesion may be in category 4 and 5. So if it is in category 1, then the cancer is quite unlikely. Means there is very less chance that the prostate is cancerous. Very low like chances are there. And if it is lie in category 2, it means still the chances of prostate cancer is very low, but it may be. And whenever it will move from category 3 onwards, so it means the cancer is likely to be occur in the prostate very soon. So in category 3, cancer is clinically significant, means it is the intermediate level. If any like patient who is suffering from the prostate, and if it is like up to the category 2, then there is no need to worry. We can, with the normal medication also, we can perform the treatment. But if it is moving from category 3 onward, then we have to do the proper like biopsy, etc. And from the category 4 onwards, the chances is very high. It is very high so that we have to like do the suitable medication. And if it is in category 4 and 5, then we have to do the biopsy and other medical assessment so that we can suggest the suitable medication. So how we are using this grading, whether it is in group 1, whether it is in group 2, whether it is in group 3, means the category 1 to 5. So if the normal prostate cells are there, and then it is in category 1. So in category 1, or you can say in group 1, the normal prostate cells will appear and the cancer will grow very slowly. But if it is in category 2, like what is happening? Like most of the cell look like normal, but there is certain growth is there. There is certain slow growth is there. But once we are moving from category 3 or group 3 onwards, what is happening? The normal looking prostate cells is there, but they are growing moderately higher than the category 1 and 2. And once it is moving from group 4 onwards, so what is happening? The growth rate is very fast and their border is also not clear. They are spreading very high. So according to that, like we have to do the suggested. So how like we can use the machine learning and data science techniques in the identification of category of the prostate cancer, and what type of treatment we can suggest to the passenger. So like as we are discussing that MRI image is having the 4 feature in comparison to the normal MRI image that is having only the 2 feature, T1 weighted and T2 weighted. Here the diffusion weighted images and diffusion coefficient dynamic contrast enhanced DC is also embedded. So here first we have to do the image segmentation. So for the image segmentation, we can use the machine learning algorithms also and the deep learning algorithms also. So machine learning algorithm, as we have discussed in the previous slide, we can use the SVM and other algorithms. And if the size of data is very large and we are having the unstructured data, complex data, then we can move for the deep learning algorithm. And for that, we can use the CNN as well as deep CNN also. So if the data is very high and that is lot of unstructured data is there, then normally in comparison to the CNN, we will focus on the deep CNN, deep convolution neural network. So that will give the better output. After that, like we have to extract the features, and the features is extracted based on the shapes and the other textual parameters. And we have to select the feature that is relevant to our the basic parameters that we are focusing. And after that, we have to do the algorithmic testing and training and testing. And once we have completed the training and testing, we have to do the validation also. Like whatever algorithm we have used, whether we have used the SVM, whether we have used the CNN, whether we have used the deep CNN, we have to compare and not only perform it like on one data set, as I was saying in previous research also, that we have to perform the similar kind of operation on the different data set. So if we are getting the same kind of output, then it is normally assumed that we are going into the right direction. So for the validation, whether we are performing on the standard machine learning and deep learning algorithm, whether we have developed any hybrid algorithm, so we have to perform and justify in multiple data sets. And our proposed algorithm or the hybrid algorithm, so we have to like validate whether it is giving the better accuracy, it is improving the accuracy and reducing the complexity. So the deep learning approach is normally better whenever we are talking about the prostate cancer identification. Apart from that, here we will not use the normal MRI image. We use the MRI image so that we can get the better result. So in this particular research, most of the previous research, they have used the MRI images. So the MRI image, multiparametric MRI image, they are giving the better image. And like here we are accurately able to identify the category of the prostate cancer. So for the classification of lesions, we have used deep learning, deep CNN, that is deep learning algorithms. And with this algorithms, we are able to classify into the multi-class problems. And like as we have discussed that lesson classify into category 1 to 5. So like how we have to identify that category. So that is possible like if we are continuously training the data sets on different algorithms. First, like suppose we have trained on the SVM, then we have trained on CNN, then we have trained on K-means clustering or whatever algorithm we have used. And then we have like present certain our hybrid algorithm. So we have to compare our hybrid algorithm present with the previous algorithm. And then we have to justify that this hybrid algorithm is accurately identifying the category. So in this way, and apart from that, we have to have the role of expert also. Whether like if we are saying it is in category 2 or it is in category 3. So whether the system, the computer aided diagnosis system, if that is like giving any particular category, so we have to also take into consideration the expert advice. So if our system is giving the right kind of output, then we can accurately saying that we have done uh, the right research. Another is clinical significance classification. So like whenever we are talking about as we are saying, the healthcare sector is very much sensitive. So we have to identify the significance, whether we are identifying into the category. So suppose if on any XYZ data, we are getting into the category 1. If any ABC data we are getting into category 2 or 3 or some other category. So it is not normally expected that that is like we have done the right kind of data feature extraction. So if we are getting the same kind of category in all the data sets by using all the deep learning algorithm, then normally it is assumed that we are going into the right direction. So that is like one of the important features that we have to take into consideration. So research trend, apart from this traditional machine learning, deep learning, and data science techniques, as we all know, like a lot of research is going on in XAI, that is you say extendable AI. So by using the extendable AI, XAI, we can also understand the human's psychology and we can improve uh, the accuracy. So like a lot of researchers who are doing research in this brain tumor identification, brain tumor grading, on the prostate cancer grading and their identification. So XAI, a lot of research is going on with the help of XAI. So we can like also use these features and we can perform and we can say that we are getting the better result in comparison to the normal set. So whenever we are saying about how the XAI is helpful in the healthcare sector, so as we can say the 7 pillars of XAI in healthcare, that is improving the transparency, it is improving the domain sense, consistency is improved, parsimony interest, generalizability is improved, trust is improved, and even the fidelity is improved. So if we say about the transparency, so like the normal machine learning algorithms, the normal deep learning algorithm, they are also, we cannot say they are not transparent. They are transparent. But if we include the XAI, means here the features are included. So we are like better understanding the output. So in this way, we can say here, as we are focusing on the better understanding of the output, so we can say the transparency is included. Similarly, we can say the domain sense. Domain sense is also there in the machine learning and deep learning. But here, as we are making sense of model output, like we are taking into consideration the human involvement also. So here, with the help of XAI, we can develop human understandable system and that give a clear identification and that will basically focus and you can say that remain consistent across different models. Like if we are for SVM, we are getting the different result. For CNN, we are getting the different result. For deep CNN, so that is not advised in healthcare sector. So we have to remain consistent across different model, and that is possible whenever we include the XAI into the healthcare sector. So this is all about like some of the, you can say, the data science or machine learning techniques in the disease predictions. So the main things that you have to take into consideration while you are doing the research on the disease prediction or the disease grading or the identification, the first and foremost thing that you have to take into consideration is selecting an algorithm. So choosing the right algorithm will always give you the better output. So always select the right algorithm. That seems overwhelming. And there is like, as we are seeing that a lot of algorithm is there. So which method is best? So for what kind of that is met? Like we have to perform. If we are performing even the brain tumor identification, so it is not always advised that similarly we will perform the deep learning. We have to perform the supervised learning, we have to perform the unsupervised, then we have to perform the supervised. So trial and error should be there, that we have to perform the trial on SVM, then we have to perform on some other decision tree, some neural network. Then we can move to the k-means clustering, fuzzy C-means, and then finally we can go into the deep learning. So the selection of algorithm, the right kind of research questions, your purpose should be properly defined, and you have to perform the operations on all the data sets and get the trial and error, whatever, like whenever once you perform, then only you can say this is giving the better outcome. So do not always, like whenever you are doing the research, do not always think that this algorithm always give the result. You have to prove yourself which is the best. That is like one of the psychology that is normally used in the research, the selection of right algorithm and with the justification that why this algorithm is best. So this is all about today's experience sharing on zero to advanced data science techniques for the disease predictions. So thank you once again to the RMK Engineering College Principal Sir and Madam Angaramaya Madam for giving the chance to share my views. Thank you again. Thank you.
Thank you, sir. Thank you. Thank you for being with us today. It's like the neck of the moment when we were requested, immediately you accepted our request and you graced this occasion with us. Wonderful insight you've given about the topic. Thank you.
In half an 90 minutes, I try to cover like most of the topics. So hope the faculty is benefited.
Thank you.
Whenever any help is required, if anyone wants to do the research in these particular domains, most welcome. Anytime you can contact.
Sure, sir. Thank you, sir.
Thank you. Thank you.
Thank you.
Thank you so much, sir.
Thank you.
On behalf of RMK Engineering College, I would like to extend our heartfelt gratitude to Dr. Munesh Chandra Trivedi for his insightful and enriching session. We are deeply appreciative of the time and effort you have dedicated to sharing your knowledge with us today. Thank you once again for being here and making this session a memorable one. With that, we bring today's session to a close. On behalf of RMK Engineering College, we sincerely thank you all for being a part of Generic Talk Series 18. We eagerly look forward to your participation in our upcoming events. Thank you.
Thank you. Thank you, madam.